You want to enclose a rectangular field with five internal partitions as shown, right? Five little sections for animals or something. If the area of the field must be 13,900 square feet, what dimensions will require the least fencing? Note the internal partitions also require fencing. So say you're gonna make it some pins for some animals. You're a farmer, let's say, or you're warehouse manager and you're setting up a warehouse to get to store a certain amount of bins, and you got to have five like aisles or sections for different animals or whatever, and you have to have a certain amount of area, 13,900 square feet, because that's how much space the animals need or the bins need in the warehouse, whatever, and you'd like to use the least fencing possible. Now, you can make this thing long and thin like this and make fives. Probably not. That's going to be more fencing, huh? You probably should make it more like this, huh? And do five, three, four. That'd be five sections. More like that. That'll use less fencing, perhaps. Anyway, so what is the shape that will use the least fencing possible and still give you all the area you need in five different sections? Now, this problem comes in different versions. You could have five sections, four sections, three sections, two sections. I think it might go up to six or seven. I don't know. There's different amounts. So anyway, so I'm showing you with five. So how do we do this? Well, it says we'll label the width W and the length L according to the diagram above. So this is the length L, and this is the width W. And then it says the formula for the amount of fencing in terms of W only is, boom, okay. So let's just start. What's the amount of fencing? The amount of fencing. Well, we'll have a length and a length, right? The length is all the way top and bottom, so 2L plus, and then we'll have a width, a second width, third width, fourth, fifth, sixth width. And that's all the fencing, right? So two lengths and six widths. But they want it in terms of W only, no L. We don't want L in there. Well, how are we going to do that? Well, that's going to come from another formula. That's going to come from the area. The area of the rectangle, remember, is supposed to be, well, first off, what is the area of a rectangle? It's length times width. And they said we need it to be 13,900 square feet to hold all the animals or the inventory or whatever. Right? You know the formula for the area of a rectangle is length times width. So we can solve, what do we want? We want W only. So let's solve for L. Boom. So L is 13,900 over W. And then we can take the fencing formula and plug that in. So I bring this fencing formula down here and I go, okay, fencing equals 2L plus 6W. You go, oh, grab that, plug it in for L. So it's going to equal 2 times 13,900 over W plus 6W. This is 6W. This is 2 times 13,900 over W. There we go. There's the formula for the amount of fencing in terms of the width. Now, this is just the setup. In another problem, we'll finish this up. We'll say, okay, now that you get that setup, now take the derivative. Now you want to find minimum fencing, least fencing possible to achieve your goals of area and having five sections. So take the derivative of this, set it equal to 0, and find the width that'll minimize the amount of fencing. Very practical for all kinds of applications. And there we go.